Okay, good morning or afternoon. We are going to start on the very last thing in this unit, and that is area of a regular polygon. Remember, a regular polygon means all of the sides are the same distance apart. So if I look at this definition, it says that the distance from the center of a polygon to any side is called the apothem. That is a new vocabulary word. Now the distance from the center to a vertex, that is your radius. You're used to seeing that in a circle. But you can also have a radius in any polygon. That is from the middle to a point. The apothem is from the middle to a side. So if you look in this figure over here, from the middle to a point, that is your radius. From the middle to a side, that is your apothem. Now here's one last formula we have to know, and that is finding the area of a polygon, a regular polygon. That is 1/2 of your apothem times the perimeter. It's a very similar formula to finding the area of a triangle by itself, but it's not quite the same. So I'll show you the little differences, and we will make it easier doing these practice problems. So if you look at problem number 1, that is a triangle. However, if you look at where that 7 is, that 7 does not go all the way through my triangle. It's not the full height. It goes from the center to a side. Center to side is my apothem. Now, because all of these are regular polygons, that means all of the sides have to be the same. So it's going to give you one side length, but that means all 3 sides of this triangle are going to be 24.2. Now, all I'm going to do is plug in my formula. So I know its area is equal to 1/2 apothem times perimeter. Well, I don't have the perimeter quite yet, but rather than doing multiple steps, we're going to do it all in one step. I'm going to say the area times 0.5, because it's easier to type in the calculator, times the apothem, that's from the center to the side, that's 7, and the perimeter. So I know the perimeter is just all of the sides added together. I can also say that as all of the sides, or as one side times the number of sides. So there are 3 sides in a triangle, so I would say 3 times the one side it gives me, 24.2. Now if I type all of that in my calculator, it'll give me the formula, or the area for this regular polygon. This formula is very straightforward that way. So the area of this regular triangle is 254.1 feet squared. Excuse me. Let's try it again in the next figure. If I count the sides in this figure, I've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Lost my count. So I know that there are 8 sides. I'm just going to make a note of that so I don't forget. Remember, apothem goes from center to a side. So here's my apothem. Because this is a regular polygon, all 8 sides are 13.3. So in order for me to figure out the perimeter, I'm just going to add 13.3 8 times. Or I can say 8 times 13.3. So I'm just going to fill in my formula now. I've got area, 0.5 is easier to use, 16, and the side times the number of sides. When I type all of that in my calculator, I get 851.2 centimeters squared. Now if you don't like doing it like this, you can do it separate and make that an extra step. You would just say 13.3 times 8, and instead of putting it in this parenthesis, you would solve it and then just have the perimeter number. Now you can also find the apothem or the side length using this formula. There's just a few more steps. So I'm going to color code these steps using a highlighter and a pen. If you don't have colored pens, you can use colored pencils. It would work too. My first step, I'm going to do in purple. My second step, I am going to do in yellow. my last step, I'm going to do in green. Then I'll do my formula in some other color. So if we read through these steps, it says first you have to create a right triangle by drawing the apothem and the radius. Now remember, the apothem goes from the center to a side, where the radius goes from the center to a vertex or a point. Then you're going to use this formula here in the parentheses to figure out the sum of the interior angles, and we're going to divide that number by 2. Then after that, we have to figure out either special right triangle or trigonometry so we can find the side length. Once we find the side length, we can find the perimeter. We're going to do this with 3 different problems. If you have questions after this, please ask your teacher. So first, in purple, we're going to make the right angle. So I've already got my apothem here, from the middle to a side. Now I have to make a right triangle by going from the middle to a point. So there is my right triangle. Next, I'm going to figure out the measure of the interior angles where the radius intersects the vertex. That's this gold or yellow part that I just marked on the triangle. Zoom in a little so you can see better. So this is the formula you're going to use. Big S is equal to the number of sides. Well, if we count them, 1, 2, 3, 4, 5, 6. I've got 6 sides times 180 all over 6. So it's the same formula if you think back to 2 units ago. Or was that last unit? I don't remember anymore, but it's the same formula. I'm going to type this whole thing in my calculator, just how it looks, and it's going to give me 120. Now, if you read the very last part of this statement, it's kind of cut off on the video, but it says then divide by 2. I'm going to take that 120 and divide it in half. I've only got half of what my side is here, so that is why I'm dividing it in half. That gives me 60 degrees. So that means I'm going to end up using a 30, 60, 90 triangle because that gold angle is 60 degrees. Now if you think back to special right triangles, it was a few units ago, I know. A special right triangle that is 30, 60, 90 follows this format. My short leg is x, my long leg is x times the square root of 3, and my hypotenuse is 2x. That is the reminder of a 30, 60, 90 special right triangle. So if you look at what's given to you here, that's this 5 meter. Is that 5 meter a long leg, a short leg, or a hypotenuse? It is the long leg. So I'm going to plug into a formula so I can find for x. We're doing this in green. I am doing this in green. You do it in whatever color you want. So normally, the long leg is x times the square root of 3. So that's what it normally is. My triangle is telling me that x times the square root of 3 is going to be equal to 5. So in order for me to find x, or the short leg, this piece right here, I have to get rid of that square root of 3. Right now it's saying x times the square root of 3. So to undo that, I'm going to divide both sides by the square root of 3. When I divide 5 by the square root of 3, I'm left with 2.9. That means this tiny little piece here is 2.9. Now if you look at that side length, that is only half of the side length. So in order for me to figure out what one whole side is equal to, I'm going to have to multiply that by 2. So 2.9 times 2 gives me 5.8. That means one side is 5.8. Now that I've got that, I can go in and I can fill in my area formula because I have the apothem and I have what I need to find the perimeter. So in case you forgot, its area is 1/2 apothem times perimeter. So that is area is equal to 0.5, easier for the calculator, times the apothem, which is 5, times what we just found, 5.8, times the number of sides, which is 6. I know this seems like a bunch, I really understand that. There are very few problems like this that you'll actually have to practice. That gives me an area of 87 meters squared when I type it in the calculator. Okay, let's try again with this triangle. So remember the 3 steps and then we'll find the area. So first step in purple, I'm going to make a right triangle by making the radius. What is given to me right now is the apothem. From the center to a side is always your apothem. Now, I have to do the formula here to figure out the angle that is going to be where those two things intersect. That is what I marked in gold. So that formula uses the number of sides. Well, right now there are 3 sides. It's a triangle. So I've got 3 minus 2 times 180 over the number of sides, which is 3. If I type that in the calculator, I get 60. And remember, that is only half. So I've got that is whole, and I only need half. There we go. So I've got to divide that in half. 60 divided by 2 gives me 30 degrees. So this, again, is a 30, 60, 90 triangle. So we're going to use the same little pencil drawing that I did at the bottom of my paper before for this one. Short leg is x, long leg is x times the square root of 3, hypotenuse is 2x. Okay, so right now, if you look at what is given to you, I am given the short leg. So this is a bunch easier. I have the short leg and I need the long leg. So right now, I know x is 18. For the long leg, it's just x times the square root of 3. So that just becomes 18 times the square root of 3. And because I don't want to leave the square root of 3 there, that's way too hard to work with, I'm just going to find the decimal form. The decimal form of that is 31.2. And because I have half, but I need the whole side, so I can figure out the perimeter, I'm going to multiply that by 2. That gives me 62.4 millimeters for the side length. So this whole side here, and all of the other 2 sides are 62.4. Now I'm just going to fill in my formula. Area is equal to 0.5 because it's easier, times the apothem, which is 18, times the side measure, times the number of sides. When I type all of that in my calculator, I am left with 748.8 millimeters squared. Feeling better about it, I hope. Once again, I understand it's a lot of steps. I hope doing them in different colors helps you. We have one more to do. So looking at number 10, looking at number 5, I have an apothem of 10 inches. Remember, from the center to the edge, apothem. So I've got to go back to the steps I just did. I'm going to make a radius to make a right triangle. So I've got that there. Kind of cut off the 10 inches a little bit, but that's okay. Now, I've got to figure out, excuse me, so yawny today. I've got to figure out, using this formula, like we did before. Using this formula, like we did before. I've got to figure out what angle measures I'm working with, so I know if I'm working with a 30, 60, 90, a 45, 45, 90, or a trigonometry triangle. So I've got 5 sides here. So S is equal to 5 minus 2 times 180 all over 5. If I type that in my calculator, I'm left with 108. And because that is only half of the angle that I need, I'm going to divide in half. And that gives me 54 degrees. So that means this angle is 54 degrees. Now, 54 does not fit into 30, 60, 90 or 45, 45, 90. So that means I'm going to have to go back to trig. I know that is kind of a scary thought, but we can do it. So if you go back to the trig and you remember, you've got so, ka, or toa. This 10 inches is supposed to be right there. If I'm looking at this angle, I don't have the hypotenuse. But I have the adjacent, and I need the opposite. So out of so, ka, or toa, excuse me, I need toa. I don't have any hypotenuse, so I'm going to, too far, I'm going to use toa. Now I have A, so that means I will set it up like this. 10 times the tangent of the angle that we found, which was 54 degrees. Oh, I gotta type in the calculator. So remember, because it's been a little while, if I go to trig, that's where I can find these. So I've got 10 times the tangent of 54, which would give me 13.8. Now remember, that is only half of the side length that I need. So in order to find the whole thing, I'm going to multiply it by 2. 13.8 multiplied by 2 gives me 27.6 inches. So that means each of my sides is 27.6 inches. So now I'm going to fill in my formula. I've got the area equals 0.5 of the apothem times the side length times the number of sides. And there are 5 sides in this shape. So if I multiply all of this, 0.5 times 10 times the side length times the number of sides, I should end up with 690 inches squared. Please reach out to your teacher if you have questions on any of these. I understand that they are kind of complicated, and we are here to help. Good luck with all of the rest of your stuff.